Um, okay. Hi, I'm Rachin, and today I'm going to be talking about what the hell multi-settlement networks are and how it enables centralized exchange-level experience with trust-minimized guarantees. Okay, so traditionally, constructs like layer 2s have been able to tap into the underlying base layer's distribution by having a trust-minimized bridge with the base layer. And we've seen this with protocols like Arbitrum, which was able to tap into Ethereum's TVL of like over $1 billion within 10 days of its launch, while networks like Avalanche, which launched on the same time with similar level of excitement, took more than 6 months for that, which helped Arbitrum bootstrap its ecosystem much faster. And then we've got the story of Base, which was able to rapidly grow its ecosystem thanks to it being able to tap into Ethereum's distribution. So, but the problem is, distribution is not persistent. So locking into a single base layer or a single source of distribution is actually could be very harmful for you, application developers, because what's relevant today may be completely irrelevant tomorrow. So, and in today's world where there's a big world of distribution outside Ethereum's land, where we have got things like BitVM on Bitcoin, Solana bouncing back stronger than ever, and there's a lot more chains that could provide you with great distribution outside of that. So for applications, locking into a single source of distribution actually could be a great opportunity cost. And that is something that you do not want to happen as an application. So the question now is, can an application or a chain tap into multiple sources of distribution with ease and with trust minimized guarantees? And yes, the answer is multi-settlement networks. The idea is, as a network, instead of settling on a single chain, if you could allow settlement on multiple chains incrementally, then as an application, you don't have to think about the underlying complexities, but tap into multiple sources of distributions across different chains. And I've mentioned the word settlement a couple times, and sadly I've only got 5 minutes, but it's such a big debatable topic. So if you want to learn more about settlement, you should go and follow the Gruel, John, and Toli on Twitter. They fight a lot about it. All in all, in a very high level, the way Twine works is that we've got settlement contracts on multiple chains we support, and then there's this off-chain component which processes the transactions. So after processing a transaction, it creates a state and the proof of the state update, and it sends that to all the chains that we support and settle on. And then for the next batch, it retrieves the storage proof to check this, if the state across the chains for the latest batch is synchronous or not. And then for some reason, if one of the settlement layers acts maliciously, or one of the bridge contracts has a different view from what the actual settlement, what the actual other networks have, the view of the state of Twine, then in that case, the Twine follows this majority view of the state across different chains. So this means even if one of the settlement layer goes down, Twine continues to progress without any hiccups. So in some ways, it is actually more secure and live than like single chain constructs. So at a very high level, like the way it works is like it uses underlying chains as a validators to create a history of Twine state from its genesis using batch number as its unit of time. And it allows us to tap into the underlying base layer security for almost free. So all in all, at very high level, the idea is that now application can focus on what they should be actually focusing on, which is the core application logic and how do you serve users better, while Twine handles all the underlying complexities of serving, or of like, getting the distribution and like, tapping into multiple chains at once. So yeah, that was it from my time, guys. I can be found anywhere in this channel. And if you got any ideas to discuss, would love to chat. Thank you so much.
Yeah, and with